Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. In this video, we're going to take a look at how to expand logarithmic expressions. So let's go ahead and get started. So essentially, what we're going to be doing in this video is we're going to be utilizing the various properties of logarithms, product property, power property, quotient property, inverse property, etc., to try to expand a logarithmic expression. So let me go ahead and show you the example here the two examples I have here. We're going to start with the first one. And so this is what we have. We have a condensed log base 2 with an argument that is as follows. 5x to the fourth power, y to the second power, like that. So we want to expand this. Right now it's condensed, and otherwise it's pretty much as simplified as it can be. And what we want to do is we want to expand this out just for the sake of practicing using the different properties. So the first thing that we're going to do is we're going to use the product property. And again, I'm not going to re-explain what that is because that would take up a lot of time. But basically, you have log base A times the quantity of n, like so. That could be the same thing as log base quantity A m plus log base A times the quantity of n, like that. We talked about that before again, but I can't reteach everything every single time. So basically what's going to happen is this. We're going to get log base 2 times the quantity of 5 here, like so. So log base 2, because everything is base 2. And then we got the 5 up top, like so, plus log base 2 x to the 4, and then plus log base 2 y squared. This is an example of using the product property. And so this expression down here is the same as this one above, but it's stretched out. But we're not quite done. We can actually do more. And so what we can do next is we can now use the power property. So we're going to use the power property next. So now we're going to go down here and power it up, I guess, if you want to use a joke like that. And so we still have our log base 2 times the quantity of 5, or times with the argument of 5, plus, now watch what happens here. I bring this exponent down in front, like so. So now it's 4 times log base 2x plus 2 log base 2y, like so. And essentially we're done at this particular point right here. You could get an actual number for this log base 2, but we haven't quite learned how to do that yet. You could put it in a calculator, on the internet or something. A lot of standard calculators don't do it unless you know the proper procedures for it. And so this is pretty much our answer right here in at the bottom here. Using our different knowledge of the different properties of logarithms, we were able to expand this out. By expanding, we just have a longer expression of the original expression. This is the condensed form. In the next video, we'll talk about condensed form, but we're not quite there yet, condensing things. Let's do the next example, and this one's kind of messy. So here's our next example. We got log base 4 with the argument or times the quantity of the 5th root, like so. Whoa. The 5th root, and inside that we have x to the 4th over 2y to the 3rd, and then we have z to the 2nd power, like so. So this is quite a messy problem here. What do we do to go about dealing with this? Well, the first thing is we have to take our knowledge of exponents and we have to rationalize the exponents. So we're going to deal with this guy right here. And so the first thing we're going to do is as follows. We're going to have still log base 4. And then what we're going to have here is we're going to have everything that was in here before, x to the 4, 2y to the 3rd times z to the 2nd, all this raised to the 1/5 power. This is an example of rationalizing the exponent, if you will. And so that's the first that we have to do. Now the next thing that we're going to do is that notice that we have this thing here raised to the 1/5 power. So if we use our power property, we can move that right here in front of our logarithm. So it's going to be written as follows. 1 over 5 times log base 4. And then all the rest is going to be the same for now. X to the 4 over 2y to the third z squared, like so. Now, the next thing that we're going to deal with is we have this fraction here. We can use something called the quotient property for that. And so you guys know the quotient property when you have, log m over n, base a, it's the same as log a m minus log a n. We talked about that before, again in a previous video. So when I do that, I get the following. This is what I get. I still have my 1/5 out here, my 1/5, but now I have my log base 4. That has not changed. Log base 4 to the x4 like that. I put that in parentheses. Oh, hold on, let me put that in parentheses. X to the 4 like that. And this is going to be outside, so I need a parenthesis right there. And then I have minus log base 4. And then I have inside that, I have my 2y3 to the third power. And then I have my z squared like that. So this is an example of the quotient property. So, we're making our progress here as much as we can. Let me go ahead and move to the next screen because I'm running out of space. I will rewrite this. So I have log, I have 1/5. Then I got log base 4, x to the 4th in parentheses minus log base 4. And inside that we have 2y to the third and then z squared, like so. So that's the quotient property. Now the next thing that we have to do here is the product property for the information that is inside this guy right here, the product property. So that's what we're going to do next for all of these, as a matter of fact. Yeah, let's see here. So I end up with the following. When I do the product property, I end up with the following. So I still have my 1/5. Yes, my 1/5. And then I have my log base 4, x to the 4, like that. And then minus log base 4. This is all in parentheses, by the way. Let me do that. Log base 4 to the 2. Okay. And then I have plus log base 4 to the y to the third power plus log base 4 to the z squared, like so. So this is what I'm doing. I'm trying to simplify this guy right here. That's what I'm doing. And so again, by using the product property, I'm able to separate these out so that they're all added together like so. That's all we're doing here. And so from there, we can now take the next step and use the power property. And so the power property is where you bring the exponent and you put it in front. We've talked about this in prior videos, so I could just show you what it looks like. So again, to make this as simple as possible, I still have 1/5, but now I move this guy, this 4th raised to the 4th here, so now it's 4 log 4x minus, so now we got log 4(2) plus, I bring this guy in front like so, 3 log 4y plus, then I bring this 2 in the front like so, 2 log to the 4z, like so. Now we're getting very, very close to being done. So on the next slide, what we're going to do is as follows. We're going to remove these parentheses by multiplying everything by -1 essentially. And so this is what I get when I do that. I still get the 1/5. That's on the outside. Then I got 4 log 4x minus, excuse me, it's kind of messy, minus log 4 2 minus 3 log 4y minus 2 log 4z, like so. That's what we have there. And then of course I got to put this in parentheses like that. And so the last thing we want to do is we could simplify this log 4 2 if we wanted, and that would just be 1/2. So instead of writing out the whole thing, I guess just say another way to put this would be just put 1/2 right there. And that is pretty much your answer. So you can see there's a lot of work involved, and it takes being very, very comfortable with understanding all of the different options you have available when you're trying to expand a logarithmic expression. It's not simple. But let me go ahead and back up from the beginning and try to recap what we did and conclude the video. So in this video, we learned about how to expand a logarithmic expression. And so by expanding, you use your different properties, the different tools of the properties, to find a way to, unravel a logarithmic expression. So, the steps and the order really depends on what the problems are in terms of the expression and how you want to unpack it. But again, in this first example right here, we use the product and the power property to expand the logarithmic form. So we started with log base 2 times the quantity of 5x to the 4y to the second. That's up here. And then we use the product property to have everything add across like this because they all have the same base. And then we use the power property to take the exponent and move it in front of the logarithm like so. And that's how we did that. Now this next one was much, much messier. We were still trying to do the same thing of expanding, but we had to utilize many, many more steps. So 1, 2, 3, 4, 5, about 6 steps to solve this one. So we started with the rational exponent. So we took this fifth root right here and we made it 1/5. That's a way to get rid of the radical, if you will. And then after that, we had to use all of our skills that we had available to us to try to deal with this. And so then we used the quotient property right here. So let me just go ahead and, so this was the rational exponent, rationalize the exponent, excuse me. And then right here, we have the, the rationalize goes right here. And then right here, we have the quotient property. And then let's see here. And then after the quotient property, we did product. This is product right here. And then after product, we did power. And then after power, it was just a matter of dealing with the negative sign here. So multiply by 1. So just multiply by -1. And then we finally had our answer right here. So again, you have to be able to look at the logarithmic expression and try to determine what is the best course of action to try to expand it. And so that just takes time and practice. It's hard to give you the specific steps, but when you start to see the patterns, it's very easy to execute. So I hope this video was useful for you. My name is Darren Thomas. I'm the Director of Educational Research Techniques. Take care.